Good evening. Hey everybody. Hello Internet. Good evening. Welcome to Everyone Loves Math live from Monday night. You love Mondays. So yeah, I'm Joey. This is my website, Everyone Loves Math. This is my Twitch show, Everybody Loves Math. Let me tell you a little bit about what I do here and how you fit in. So let's start with this. Check it out. This is everyonelovesmath.com. That's my website. So in between these Twitch streams, you can find me over here. You can catch me outside. I'm right here. So everyonelovesmath.com. That's my website. There are a couple things on here that you should know about. One is you got the About Me page. For those of you that would like to, right-click on that picture of me, save it, make it your desktop, go for it. Go for it. Why not? Let's see. What else do I have on this page? I'm turning down the mic a little bit. I've got a tutoring page. So if you want some one-on-one assistance, you can book a session now. I got spots filling up this week, but there still are spots for Wednesday and Thursday, and I think some half-hour spots for Tuesday. So we got you there, and let's see, there's a message board, so you can join my message boards, and this is another place where you can chat with me, ask questions in between shows. There's two levels of support. One is a free level, and one is $5 a month, and for right now, you would sign up for the $5 a month if you just want to support what's happening here. There is a VIP chat room, message board, VIP message board, that comes with that $5 a month, but that's really just supporting this show and supporting what we are doing. So that having been said, let's talk about the format of the show. So right now, what I do is I take questions, math questions off of Reddit's homework help, and it's kind of a random smattering of questions, and we kind of tackle them together here. And at any point, we can stop if I get any kind of math questions from the Everyone Loves Math hotline. So here's what you can do if you want to ask a question. I'm moving around a lot. I don't know why I'm moving. I just had some sugar. That's probably why. So if you want to ask a question, the most direct way to do it is right there in the chat. You ask a question in the chat, I'm going to be able to see it. You can also use the Everyone Loves Math hotline, which is coming. It's coming right here. Call, text, send a photo or a video to my Google Voice number. That's the Everyone Loves Math hotline, and I will do it on the show. In fact, the first two questions I'm going to do are from the Everyone Loves Math hotline. So we're going to take care of that. Let's see here. So yeah, all of that having been said, we're going to get busy. We're going to get into it. I actually have two questions, like I said, that came from the hotline, and these questions are for someone that's studying for the nursing exam. I think it's the ATI TEAS. ATTs. I don't know if there's a slick name for it, but hey man, let's do it. Let's become nurses. All right. So here's our real weird problem. So before we just start solving this thing, because that's what they want us to do, let's make sure we kind of point out some stuff that we notice. All right. So before you tackle a problem, it's always good to be like, dude, what do you notice? What do you see? So I'm going to talk about a couple things that I see. First thing that I see, which y'all are probably seeing too, is there's a fraction. So I see fraction. I see fraction. And I know we hate fraction. So maybe I got a little something for that. I don't know. Let's see. What else do I see? I see, let's see. The variable is t. There's t's on both sides. Alrighty. T's on both sides. Alright. And then, because there's a t there. And then on the other side, there's a, where is it? It's right here. Sorry, that t is part of the sentence. All right, let's see. What else do we notice? Oh, there's some distributive property. And how do we know there's some distributive property? Because there's some parentheses happening. So we know that that's going to happen. And then probably, like, one of the more important things about this problem, This is an inequality. So this particular problem is a greater than or equal to. What that means is that we have to just be a little bit careful when we solve this inequality, and we'll talk about that carefulness when it comes up. All right, so there's a bunch of stuff going on here. So let's see, what do we want to do first? So I think, like, we kind of have to tackle all of this. I kind of think we can take care of the distributive property without too much trouble. And I think if we do that distributive property, then we'll be looking at something a little bit simpler. We'll be able to kind of take stock and go with our next step from there. All right, so let's give that a shot. So if I'm going to do the distributive property, I'm just going to give myself a little bit of space here. I'm going to copy the 1/2 and the plus 3t, because we haven't done anything with that yet. So I know I'm putting it down here. I'll move it up once I, you know. All right, so we got 1/2 plus 3t is greater than or equal to. Now it's time to distribute. We do them, ooh, you guys can't see this, the original problem. How about that? We do them little rainbows. Y'all remember them rainbows? Rainbows. This -2 has to get distributed to the 1 and to the -3t. All right, let's do it. I'm going to distribute -2 times 1, and I get -2. If I distribute -2 times -3t, then I get positive 6t. And then I still have that -3/4 hanging out. All right, so there we go. So we took care of the distributive property. Things are looking a little bit more simple, right? Every step of the way, we want things to look a little simpler. So up next, you know, if we wanted to like put on our big boy pants and our big girl pants, we could just handle these fractions. Like, we could just deal with it. But I don't know if I want to. Yeah, that's where you have to decide. So I think what I'm going to do is I think I am going to do a little bit of math to get rid of the fractions. Let's play that game. So if you look at our denominators in this problem, the two denominators in this problem are 2 and 4. So the lowest common denominator between 2 and 4 is 4. I'm going to multiply both sides of this inequality by 4. Now, multiplying both sides of an inequality is a legal move. We know that it's going to make all of the numbers bigger. In fact, it's going to make them 4 times the size of what they were before. But at least there won't be any fractions. So after you see this step, if you're the kind of person, you look at this and be like, I never want to do that, then don't do it that way. Do it a different way. All right, hold your own marker. All right, so now what we're going to do, though, is we got to do a whole bunch of distributive property. We got to take this 4 and distribute it. Boom, boom. And then we have to take this 4, and we're going to distribute it to all 3 places. Boom, boom, boom. We got some work to do. Let's do it. All right, so 4 times 1/2. I'm going to do this in the interest of time. 1/2 of 4 is 2. 4 times 1/2 is 2. All right, plus 4 times 3t would be 12t. Then we got greater than or equal to. All right, now we got 3 distributive properties we got to hit. So let's do it. 4 times -2, that's going to be -8. 4 times 6t, that's going to be 24t. And then 4 times -3/4 is just going to be -3. How do I know that? Because the 4 in the numerator would cancel with the 4 in the denominator, which is why we did that whole thing. So take a look. Or I guess I have to point over here, even though it's over here for me. No more fractions. So no more parentheses, no more fractions. That's looking great. So now the only thing we have to do is we have to take care of the fact that there's variables on both sides. We got to get all the variables together. That's what I would say first. Get these t's together. So we have 2 options. We can bring all of the t's over to the left or bring all the t's over to the right. So here's how I like to do it. I like to take a look and ask myself what's going to be easier. So we got a positive 12t and a positive 24t. So let's talk about what it would look like to move these to the left and what it would look like to move these to the right. So if we moved everything to the left, we could minus 24t on both sides, right? Put a minus 24t there and a minus 24t. we could do it, it'd be fine. We would end up with negative, right, 12 minus 24, that would be negative. What if we moved all the variables to the right side? So if we moved all the variables to the right side, we could do that, and actually, that's what I want to do. We could do that by subtracting 12t on both sides. Boom, boom. And if we subtract 12t on both sides, then all the t's are going to be over on the right, but at least they'll be positive. All right, and I would rather not deal with negatives. You know what I mean? Are you with me? All right, so let's figure out what we would have here if we do all this. So over on the left side, 12t, take away 12t, though, that just goes away entirely. So the entire left side is just that 2, that constant 2 that was hanging out. All right, over here, what are we going to do? Well, I'm going to combine like terms with this whole 24 minus 12t business. If I have 24 t's and I take away 12 t's, then I'm left with 12 t's. All right. And then how about our plain old numbers? So for plain old numbers, I see a -8 and a -3. -8 and -3 combine to make -11. All right, so think about all this work we've done. And we, you know, like most of this we had to do, but the fraction stuff we did to make our lives easier. But every step that we did it based on what we observed. So take a look. T's are on both sides. We took care of that. Fractions, we took care of that. We still haven't talked about the inequality, but we're doing a good job. We're kind of, all the steps that we're doing is to take what we had and to make it more simple. So now if we look at this, we're left with a 2-step inequality. If there was an equal sign there, this would be a 2-step equation. And so we're going to do a little home stretch, right? We just got to get t by itself. We're going to add 11 to both sides. All right, so we add 11 to both sides, and what do we end up with here? 2 plus 11, that'd be 13, is greater than or equal to 12t. And to get t by itself, we could divide both sides by 12. So we're going to totally do that. And we end up with our answer. So we got to be careful, but we do get our answer here. So we end up with 13 over 12 is greater than or equal to t. Okay. So does that match one of the multiple choices? Well, look at that. The top 2 are looking pretty good, right? Because the top 2, if I'm looking at these, I know it's going to be one of these first 2 answers. It's got to be one of those. These are already out. But be careful. We want to make sure to get this symbol right. So I'm going to scroll back down and take a look. This says 13/12, the fraction, is bigger than t. Well, if the fraction is bigger than t, that must mean t is smaller than the fraction. So the answer would be that first choice. We have to reason it out because we have, in the problem that we worked, we ended up with t over there on the right. And so with an inequality, oftentimes the very last step is the one you have to think about. If Michael Jordan is taller than me, then I am shorter than Michael Jordan. If 13/12 is bigger than t, then t is smaller than 13/12. And we got it. That's it. Chalk it up. Chalk one up. Victory. All right, next up, word problem. Y'all love it. This word problem, this one is actually kind of real life, man. So let's take a look. It's real life because it's like kind of sloppy. A developer has a plan for a 75 home neighborhood. So we're going to have 75 homes, each that has a lot size of 30 meters by 20 meters. So you can imagine all these, like, that's going to be a rectangle. So 75 of these rectangles, that's going to make like a little neighborhood. Okay? If the streets between the houses will add at least 20% more area, which of the following commercial real estate listings would be the closest to the needed size? Okay, so this is a problem about area. And that's the weird thing, is you read this whole thing, you have to make sure that you know this is a problem about area. And so what we're going to do is we can draw some pictures, we can make sense of this problem. So let's make sense of this problem. So the first thing to know is that we have 75 times, right? There's going to be 75 homes. And each home, this isn't going to be an equation, by the way. I'm just going to draw the picture right now. So it's going to be 70 times 30 meters by 20 meters, right? And then we have to add 20% more. Right? That's what the problem says, is we do 75 of these plots and then add 20% more. And then we'll go back and compare it to the multiple choice. All right, so let's take care of business. Now we're going to get a little bit more algebraic. I don't even think we need to do algebra here, but we'll just make things look official. All right, let's get official. So what do we got? We got 75 times 20 times 30 is going to be 600. And that's square meters. We don't have to put the units. It's just us working this problem, but, you know, not a bad idea. So 75 of these 600 square meter plots, but then we need to add 20% more. So I bet you that's where this person got stuck. So let's kind of talk about a synonym of add 20% more. If we're adding 20% more, doesn't that mean we really have 120% of what we started with? All right, so remember, 75 times 600, that would be 100% of the homes. We want to add another 20%. So what we are really interested in is 120% of the area. So we have our area for the homes. We're going to multiply by 120% to factor in that extra 20% for the roads, and then we will get our overall area needed. So here's where I bust out my trusty calculator, and we're going to do these multiplications. 75 times 600 times 1.2. And remember, on the nursing test, you guys might not know this, on the nursing test you do get a 4-function calculator for all the problems. All right, so this comes out to 54,000 square meters. So in order to build these homes and factor in the extra space we need for the streets, we need 54,000 square meters. Now we go back to the multiple choice, and we have to see 54,000 square meters, okay? So let's look up here. So the one piece of information we definitely need is this thing about it. Ooh, that highlighter looks horrible. Let's not use red to highlight, like ever. Okay. Should I try yellow? I'm scared to try now. All right, a hectare. Oof, that looks bad. I'll underline it. So a hectare is equivalent to 10,000 meters. So they gave us that information because several of these multiple choice include hectares, okay? So let's look here. The first one, 1.5 hectare, or I'm sorry, 5.1 hectare. Well, 5.1 hectare would be 51,000 square meters. All right, that's looking pretty good. That's off by 3,000, right? We need 54. So here's the weird thing, right? The multiple choice said, which of the following is closest to the needed size? So in my logic, I'd be like, well, it can't be A because A isn't enough square meters to hold the 54,000. But it didn't say, it didn't ask the question like that. It just said which number, which of these is the closest. So even though 51,000 square meters would not be good for this problem, it is close to the answer. So let's just file that for a second. Okay, so let's see. For letter B, 200 times 300, that would be a 6 with 4 zeros, right? If we were doing our multiplying, a 200 by 300 plot. So we know we multiply 2 times 3 and then put on the zeros. This would be 60,000 square meters. Now, the first choice was 51,000. That's closer. So I'm thinking, so far, I know that that one's far away. All right, next one, 4.5 hectares. Well, that's 45,000 square meters. Remember, because each 1 hectare is 10,000 square meters. All right, so 45,000. Now 51,000 is still closer, so I wouldn't pick that one. Let's look at the last one. Near Swindon, there is a 500 by 110 meter area for residential development. Well, what happens if you multiply those? You get a 55 with 3 zeros square meters. All right, now listen, we needed 54,000 square meters. This last choice says there's 55,000 square meters out there. So this last choice, this is only 1,000 square meters away from what we need. It's going to be that one. That's the big winner, that last one. All right, so we can cross this one out. So we have to be careful, because if they said which of these would be the smallest possible one that would work, then that would be 55. We want to make sure to always be using our common sense. Okay. Here's another, so here's a question from Reddit's Homework Help. And I really like this one because the person that asked this question, not only did they kind of have a question, but they put out what they worked on, so you can kind of like read what this person's thinking. So this person was asked to factor something, and the thing that they're factoring is x minus 9 times x plus 6 squared. I'm just converting it from the like weird text to what the math text. Minus x minus 9 squared times x plus 6. And the instruction is factor completely. And so let's read what this student said. The student said the correct answer is listed as bleh. This is driving me mad. I didn't remember most of this stuff from middle school or high school, seeing I'm a 32-year-old teenager. You notice, y'all, this stuff ain't never going away. Okay? Offer. Okay, so let's see. So take your time and factor what you know basic algebra. Okay, so let us hammer this thing out. Here's the thing. Here's what I'm going to guess this person did, and this is where I feel really, really bad. If someone said to factor this to most Algebra 2 students, they would probably start multiplying this out, get it all super huge, and then try to combine like terms and stuff, and then refactor it. And whenever you're given a problem, like one of the things you got to ask is like, what do you see? So before you start to just plug away at it, what do you see? So here's some things that I would want to make sure that you see when you look at this problem. So first of all, I notice that this is not an equation. This is just an expression. So all we can do is simplify it. And we're not going to solve it. We're not going to say what x is, because it's not an equation. Okay. Other thing that we notice is that ultimately this is a subtraction problem. These are two big honking things. So we can call, I mean, these are each terms, right? This is the first term. This is the second term. But ultimately, it's a subtraction problem of these two things. Great. Now we go into really the stuff to observe. So really what I would want you to observe is, do you notice that there's an x minus 9 here and 2 copies of it there, because it's an x minus 9 squared? Do you notice that there's an x plus 6 squared here and an x plus 6 there? That means there's 2 copies of x plus 6 in the first term and 1 copy in the second term. Okay. So here's what we can do. When it says factor, there is a trick to this. Factoring is looking at these two terms and then asking yourself, what do these two terms have in common? And I think that all of us can agree that both of these terms have an x minus 9 in common. I know they both have an x minus 9 in common because there's 1 in the first term and there's 2 copies of it. Remember, it's squared, so there's 2 copies of it in the second term. So we know we can factor out an x minus 9. All right. The other thing that both of these terms have in common is an x plus 6. How do I know they both have this in common? Well, this first term has 2 copies of x plus 6, and then the second term just has 1 copy. So they both have at least 1 copy. All right, so now that we've factored out the x minus 9 and an x plus 6, then we have to write inside what's left over. So check this out. We have this x minus 9, but we factored it out. So we're not going to write it inside. We done factored it out. We got 2 copies of x plus 6. We factored out 1 copy of x plus 6. So out of this first term, we still just have that 1 copy of x plus 6. Okay, now we're going to hit minus. And now let's talk about what's remaining in this second term. So let's see. Well, we had 2 copies of x minus 9. There they are. But we factored 1 out. So that means there's still 1 copy remaining. And I'm going to put it in parentheses because it's being subtracted. And we know we're going to have to distribute. Okay? How about this x plus 6? Well, here's the x plus 6, but we factored it out. So we don't write it again. Officially, we have just factored this thing. And factoring, by the way, means we turned an addition-subtraction problem into a multiplication problem. That's really what factoring means. Now, no one would ever accept this as an answer because teachers are jerks. The stuff in the brackets, we got to simplify. You know we got to simplify. I bet y'all were like, hey, do we need to simplify that? And the answer is yes. Simplify it. All right, so I'm going to copy the x minus 9 hanging on the outside, copy the x plus 6, and now what do we got? Well, we got x plus 6, that's still there. And now what we need to do is we need to distribute that minus sign. All right, cool, cool. So what do we get? Minus times x would be minus x. Minus times minus 9 would be plus 9. All right, working that magic. Working that magic. All right, so now let's see. Well, x minus, we're just, these x minus 9 and this x plus 6, they're just chilling. They're good. We got to simplify what's inside these brackets. So let's see. What do we see? Oh, take a look at this. There's an x and a minus x. Those go together. X take away x, that's just 0. And look what's left. Stuff remaining is a plus 6 and a plus 9. So 6 and 9, that just makes 15. So we could just do this, but no one would ever write the answer like that. Well, mathematicians, we like to put the constant up front. So we would do 15 times x minus 9 times x plus 6. That is the much easier way, believe it or not, the much easier way to get the answer. All right. And for those of you asking, let's see, this would be a really hard Algebra 1 problem. This could be like a really good bonus Algebra 1 problem. Algebra 2, I'd put it on the test. But I'm a mean guy, so what are you going to do? All right, some graphing. I love graphing. I love graphing. And it's been a minute since I've done some graphing, so I want to do some graphing. Now, I want to just pick, I just like this person's work. So we're going to pick a question. We're going to tackle it together because it's fun. How about we do question number 5, which would be f of x equals the square root of x take away 5, and then a minus 1. Okie dokes. So there are a whole bunch of ways to graph this problem, and one of the ways you can see right here, maybe you can see if I did it. Oh, yeah, anywho. So this person over on the left here, maybe I can just point to it. Yeah, so this person was like making a tea table. They were like going to do some work. So we could do it that way. But we also can take a look at this function and be able to say what the function is going to look like, and then what was done to this function. So that's where I would rather go. So here's where we go. What is this thing going to look like? This is a square root of x graph. All right, so that's the shape. So the shape of this thing is going to be square root of x, and square root of x is the one that looks like that. So we know that shape. All right, the minus 5 does something, and the minus 1 does something. And so here's what we need to know. We need to know, what does subtracting 5 do inside of a function? So I'm going to switch back to my marker here. So what does that minus 5 do? This moves the graph to the right 5 units. Okay, and for right now, since we're just tackling these problems, I'm going to put that out there that the subtraction on the inside of a function, subtraction moves the function to the right. Subtraction on the outside of the function, this moves the function 1 unit down. So the outside stuff is up and down, the inside stuff is left and right. And if that's something you'd like to review, we can go over that. Just ask, and I can make it the subject of a whole evening. All right, so time to graph this thing. Well, they got graph paper, although I can't write on this graph paper. Boo. So I'm gonna scroll down. I'm gonna do my own graph. I'm gonna do my, ooh, look at this. Oh yeah, you love it. I'm gonna do my own graph over here. Okay. So I am horrible at drawing these lines. So I'm gonna do this and then this. Now I know I have like a line tool. I could make this look prettier, but you know what? I'm not. All right, so this thing. So the thing that you need to know is that square root of x looks like this. So that's square root of x. It looks like half of a parabola on its side. Okay, so what do we need to do? We need to take this thing and move it to the right 5. So I'm going to be like, I'm just going to do a different color. How about this? Move it to the right 5. So 1, 2, 3, 4, 5, and then move it 1 unit down. So instead of starting right here at 0, 0, this graph is going to start right here at 5, -1. It moved 5 to the right and 1 unit down. And then, depending on how pretty we want to make it, I would just do that, and this would be f of x. If we want to get like in there and get some more points, we could, but as far as just understanding what the graph looks like, that's it. All right, cool. I went over that kind of quick because I got a couple other problems I want to make sure to get to, but again, anything you want to see in depth, you can let me know in the chat. You can let me know on the Everyone Loves Math hotline. You can let me know in the message boards on everyonelovesmath.com. I want to make this show what's going to be best for you. All right. I thought this problem was cool. And it's an election year. Yay. This is totally different kind of problem. In a special runoff election, Larry Trusterton, that's it, vote for him, huh? Larry Trusterton. Larry Trusterton was elected county treasurer with 52% of the votes, defeating his opponent by a mere 43 votes. If the final results are 52 to 48, then how many total votes were cast in the runoff election? Okie dokie. So, I was actually just talking about this problem with a student today. You need to be able to read a problem like this and know that this is a proportions problem. Like, this to me screams proportions. All right, let's talk about how I know by looking at this that this is a proportion problem, because I want you to be able to know by looking at this in the future that it's a proportion problem. So proportion problems almost always look the same. There are two different things they're comparing. So in proportion problems, they almost always compare two different things, and then they ask you to compare two different things, and one of them they don't give you. One of them is going to be like a variable or whatever. That's like how this always works, okay? All right, so let's see. What proportion can we figure out? So we know that the two things in this problem are percentages. I'm just going to like diagram this out. So we have percentages and then number of votes. Okay, so let's figure this out. I know something about 43 was a number of votes, right? So 43 votes represented what percent? So here's where you got to be careful, because 43 votes wasn't 52%. It was what he won by. So what did Larry win by? He won by 2% of the vote. Right? He got 52%. So he won by 2% and he got 43 votes. What we want to know is how many votes, so I'll put an empty box here, were the total votes cast? Well, the total votes cast was what percent? It was 100%. So we have now set up a proportion. So a proportion that we have set up says if 2% of the vote is 43 votes, then 100% of the vote is what? All right, that should give you a proportion flavor. When you're asked it, you're given two things to compare, and then you're given two other things, except one is an unknown. All right, this, get used to kind of feeling for that problem. Now, besides everything I just said, there's one other thing you have to know about proportions, and proportion patterns, say that a bunch of times, proportion patterns are all about multiplication and division. So whenever we do proportions, when we want to look for patterns, we want to look for multiplication or division patterns. So what do I mean by that? Well, one thing we could do is we could try to look at a pattern between 2 and 43. That looks nasty. I don't want to do that. I want to look at this pattern, 2 to 100. I know that that's a multiplication problem, a multiplication pattern. We can get from 2 to 100 by multiplying by 50. And remember, with proportions, you always want to look at multiply and divide. So 2 times 50 is 100. Yes, 2 plus 98 is 100, but we don't do proportions with addition and subtraction. Multiplication and division. So to go from 2% to 100%, we multiply by 50. To go from 43 votes to the total number of votes, y'all aren't going to believe this, we multiply by 50. Because that's going to preserve the proportion. If we multiply both sides, and even though this is an equation, it still has two sides, right? Multiply both sides by the same number, we will preserve our proportion, and we'll get our right answer. So if I do 43 times 50, which I'm doing on my trusty calculator, then we end up with the total number of votes, which is 2,150. So in this particular case, there must have been 2,150 votes cast in order for that 2% win to be a 43 vote win. That's a really neat question. I really think that's a neat question. If you're somebody that's working on proportions, then that's a great proportions problem. And I can say that because I didn't make it up. I just found it. I stole it off the internet to help you. All right, y'all. Let's switch it up. It's time for a little geometry. Dare I say trigonometry. We'll do a little trigonometry. All right, how about that? All right, so let's take a peek. In the figure below, the distance from A to D is y. All right, let's look. A to D, that is y. Okay, they have that labeled, right? A to D is y. The distance from D to C is x. So they wrote D to C is x. And the distance from A to B is h. Okay, they have all that labeled. Thank you. All right, next up. If A is 27 degrees, so that angle, this angle right there is 27 degrees. And then it says AB is 14. Well, that means we don't need an H anymore. All right, so it was nice for them to label it, but if AB is 14, then don't call it H, call it 14. That's AB. And then DB is 7. Boom. Okay, they want us to find X and Y and round to the nearest tenth. Okay, so in this problem, they are giving us, here's how you know, this is a, so I'm going to write, this problem is a trig problem. And here's how you know it's a trig problem. Probably it's like the title of the test, so let's start there. But even if it's not the title of the test, whenever you're doing math and geometry, you're dealing with triangles, they almost always do it in 3 different ways. They'll give you nothing but angles, a whole bunch of angles, and you have to use the angles. Great. Or they'll give you a whole bunch of sides, like Pythagorean theorem, something like that, and you got to use all them sides. My little warning ears go off whenever I see a right triangle. That's a warning for trigonometry, and a combination of angles and sides, because we know that the trig formulas combine angles and sides. Okay, so what are we going to do? What I would recommend is, and I bet it's the reason why somebody asked about this, I think it can be helpful, but it also appears to be a little unhelpful to have the 2 triangles overlapping. So one of the things that's never like a shame, don't have to, is I like to draw these problems and separate the 2 triangles. I'm going to just take these two triangles and just make them so they're not on top of each other. And dear goodness. Okay. Let's see. So what are we going to label? So this one is like the one on the left. This triangle here is like the inside triangle. It's BCD. So I'm going to label this BCD. All right. And I'm going to label what I know. I'm going to label this is 7, this is X, and that's about all I know. I don't know what this angle D is right here. It's not 27. That's angle A. So, yo, chill. All right, so now let's do the big triangle. So that's BCA. So I'll put BCA. And now what do we know about this thing? Well, this side is 14. We know that. Let's see. We don't know the height. We know the base. If you look at this, the base of this big triangle, A to C, would be this distance right here, A to C. What is that distance? Well, this distance is X. This distance is Y. So you put them together, you get X plus Y. So that means the base of the bigger triangle right here would be X plus Y. What else do we know about this bigger triangle? The angle is 27 degrees. Okay, so now we're in business. Now we got some stuff. All right, so where are we going to start? Well, we're going to start with the triangle on the right. And the reason why we're going to start with the triangle on the right is because the triangle on the right here gives us information about angles and sides. The triangle over here on the left, we only have information about really about one of the sides, right? We know this is 7. The fact that this is X doesn't really help, okay? Because, you know, we don't know what X is. So we have more information about the big triangle, so we're going to hit up the big triangle. Got it. And here's kind of where we're at. So we're going to use trig, and we could use trig to either figure out this side or figure out this side. And you might wonder, like, I don't know, which one should we do? And we'll do both. Why not? We'll do both. We'll just have the maximum amount of information. So the only thing we need to do now is we need one more variable. So I'm going to call this W, that side W. And by the way, this is also W because BC is a shared side in both of those triangles. So I'm going to call that W, and the reason why is because we're going to do some trig. We're going to figure out what W is, this missing side. And the reason why I'm looking at this W is because this W is shared between the two triangles. And if I could figure out what this is, then we would be able to figure out what X is. We got some stuff that, you know, starting to get excited. All right, so like I said, we have the information about the big triangle, so let's do some stuff with the big triangle. So if I want to find W is the vertical piece, or we could also call that opposite of the 27 degrees. So opposite, and then we have information about the hypotenuse. Opposite and hypotenuse is sine. And again, anybody looking to review the trig functions, hit me up. I can make it the topic of a very special Everyone Loves Math Live. I promise. All right, so let's write this out. I'm going to write out for the big triangle there, the sine of 27 degrees equals the fraction W over 14. So that's just saying opposite over hypotenuse. And again, this is an application problem, so I'm not going to break this all the way down. But if you want to see it broken down, come holler at your boy. All right, so what do we got now? We got, we could solve for W. So we could multiply both sides by 14, and we would get 14 times the sine of 27 degrees equals W. Okay, now here's the hard part. The hard part is that we found a side, right? We found this side W, which they didn't even ask us for, but trust me, we needed to. And look, it's going to be disgusting. It's going to be some decimal, but it says round to the nearest tenth. So here's what I recommend. I always recommend going like 2 more places off. So what I'm going to do is I'm going to do the sine of 27, and we're going to multiply that by 14, and then I'm going to round it to like 3 decimal places. All right, just to be safe. So let's see, I'm going to hit 27. I'm going to hit that sine button, and then we're going to multiply by 14. And we end up with 6.356. All right. Now, I'm going to use that rounded number. I feel okay about it because they just want the answer in the tenths place. I went out to the thousandths place, so I'm feeling pretty good. But I also know that that this is the better number to use for W, but it's just going to make some of the calculations look crazier. Okay? All right, so 6.356 is what we just figured out W is. So what I'm going to do is I'm going to go up here and I'm going to erase W. I'm going to put in what we know it to be, which is 6.356. Over here, this will be 6.356. Okay. All right, so now where do we have this information? Where can we go next? Well, take a look at the left triangle now. Look at that. We have a right triangle where we know two of the sides. That means we can find the third side. Cool, let's do it. Let's see, maybe I'll just do it. Ooh, I'll do it right over here. I'll do it right over here. So we're going to set up the Pythagorean theorem. X squared plus 6.356 squared equals 7 squared. A squared plus B squared equals C squared. Okay, so at this point, it's time to just kind of use a calculator. All right, so I know 7 squared is 49, right? And then I'm going to subtract this off. So what I'm going to do is I'm going to minus 6 point, well, shoot. Let's see. What are we going to see? Once you start rounding, you get in trouble. So again, hopefully we're okay because we rounded all the way to the thousandths. But if we want to, let's see, we can multiply out this disgusting 6.356. So if I take that thing and square it, let's do that. We're going to take this thing and square it. Boom. We get x squared plus 40.397 equals 49. Okay, so now we can subtract this 40.397 on both sides. All right. And if we do that, then we'll end up with, let's see, those go away. So we still have x squared. We need to do this gross subtraction problem. So we're going to subtract that, boop, boop, using my trusty calculator. And we end up with 8.603. And then to get x, we have to now square root that because we have to undo that squaring. So now if we square root that, 8.603, hit the square root button, we get 2.933. So I would round, what did they say? They said round to the tenths. So let's see, if we looked at this, 2.933, they should have put in 2.9 for x, right? So x wasn't 3.6. They should have put in 2.9. All right, awesome, that was fun. So how do we figure out y? Well, we can do the same thing now with this bigger one here. We could use the Pythagorean theorem, or we could use more trig. I'm going to leave that one. We found x. Those of y'all that are working and following along, being good students, I'm going to let y'all find y. Okay? And if you text me on the Everyone Loves Math hotline, I'll tell you if you got it right. How about that? All right, cool. Alrighty. All right, let's do a little time check. Where are we at? 9:50. I might make this the last problem of the day. I feel like we didn't get through too many problems, but then again, all these like crazy problems got set up in homework help on Reddit. So here we go. Trigonometric identities. I actually have an appointment with a student, a pre-calculus student tomorrow, and I will probably discuss this one with her. So let's take a look, him or her. So let's take a quick look at this thing. Good save, Joey. They want us, I cut off the instructions. It's basically prove this identity. That's what they want us to do, is prove this. And so what we're going to do is we're going to start with the left side. The left side actually tells us some stuff to do, right? We can square that out. That's what I think. I'm like, let's take the left side, let's square it out, see what happens. Because I observed that. Like if we're talking about what do we observe, I observe a square here. So if I start with this and square it, then I might be able to get moving. The other thing I notice is this side has secants and cosecants, and secants and cosecants are the reciprocals of sine and cosine. So there's probably going to be some like 1 over stuff happening here later on. But I don't know. With proving these identities, sometimes you just follow your nose. So I'm going to start with the left, try to end up on the right. You totally could get this problem by starting on the right and trying to end up on the left. So let me show you what I mean. So we have sine plus cosine squared. So I'm going to write out what this means. This means the sine of theta, oops, sorry. Oh, that's a theta, by the way. For those of you that don't know your Greek letters yet, that's a theta. So we're going to do sine of theta plus cosine of theta. We're going to multiply that by itself. Sine of theta plus cosine of theta. That's what it means to square something. Now you'll notice I'm not touching the right side because I'm trying to take the left, do a bunch of math, and end up with what's on the right. We can't like do stuff to both sides or any of that because we haven't proven that this equation is actually true yet. So we can't use all those tricks we know with true equations. All right, so now we have to multiply this thing out. So there's a couple ways to do it, man. You could do FOIL. You could do the area model. But to be honest, I just do memorization because it's a perfect square, right? It's something times itself. However you want to get that done, multiply it out. So I don't know, maybe I'll just use, I don't know, FOIL. That's probably how most people do it, although that's not how I do it. But that's how most people do it. So let's do a little FOIL, right? So we're going to do the firsts, which is sine times sine. So let's see, maybe I'll just write this out. Sine times sine. Those are the firsts multiplied together. Then we go with the outside, right? FOIL, F-O. Outside would be sine theta, that's outside, and cosine theta. Okay, then we do the inside, which is cosine theta times sine theta. Those are both on the insides. And then the lasts, F-O-I-L, and that would be cosine of theta times cosine of theta. Okay, again, our goal is to do all this work and turn it into that right side. All right, so there's some cleaning up here to do, and you're going to be good at this cleaning up based on how comfortable you are with some algebra concepts. And don't get swayed that instead of having x's and y's, we have all these gross things. So here's what I mean. Look at this first term. This first term is the sine of theta times the sine of theta. What that is that is the sine of theta squared. And that's how we write a shortcut for the sine of theta squared. Okay, the next thing I want you to pay attention to, take a look at this. That's a sine theta cosine theta. That's a cosine theta sine theta. Those are actually the same because this second term here, the cosine theta sine theta, we could write that as sine cosine. So what do we really have here? Well, we have one sine cosine plus another sine cosine. So we have two sine theta cosine theta. Again, if you hate this, you can do all of this math. You could just say, hey, sine of theta, call that A. Cosine of theta, call that B. And you could do all of this the same. All right, what haven't we touched? That last term? Cosine times cosine is the cosine of theta squared. All right, look at us. So we took that thing, we multiplied it out. Now we got to stop and see what we have and which trig identity we can apply. And here's the one right here. Look at that. Do y'all know what sine squared plus cosine squared is? It is a trig identity. The sine squared plus cosine squared is 1. And so this is 1 plus 2 sine theta cosine theta. All right. Now, I would love to be done here, but this doesn't look like the right side. So let's go back up here. Remember, we're trying to get this. So that's got a bunch of secants and cosecants. So what I'm going to do is I'm going to convert the sine and cosine to secants and cosecants because those are the reciprocal identities. So this will be 1 plus 2 times. So the sine is 1 over the cosecant of theta. And the cosine is 1 over the secant of theta. Again, we're just using trig identities. These are things to study and memorize when you are in pre-calc. All right, so what do we end up with now? This is 1 plus. Well, if we multiply all this, there'd be a 2 up top, and then a cosecant theta, secant theta on the bottom. All right, we're getting so close. So now, believe it or not, we're close. So let's take this, let's compare it to where we want to go, right? So I see a secant, cosecant in the denominator. I see a secant, cosecant in the denominator. But this right here is only one fraction. So I need, this is going to be great, I need to add these two numbers as a fraction. I need to do a common denominator. And the common denominator is going to be cosecant, secant. So check this out. I'm going to write the craziest thing that's the same as 1. I'm going to write this. Cosecant theta, secant theta, divided by cosecant theta, secant theta. All right. So for those of you that aren't in pre-calculus or haven't taken geometry yet, you can look at this thing and not know what cosecant and you don't even need to know how to read this out loud. But isn't this something divided by this itself, the same thing, right? Same thing in the numerator and denominator. This fraction is the same as 1. And now it has the common denominator, so we're going to be able to add it to 2 over the cosecant theta, secant theta. What do? Well, we add the numerators and write it over the common denominator. So if we add the numerators, cosecant, secant, plus 2, we're allowed to do that because these two fractions have the same denominators. And then put it over that common denominator, cosecant theta, secant theta. And if you take this and use the commutative property, right, I'm not even going to connect the dots there, you end up with exactly this. All we have to do is change the order of addition, which is totally legal, right? Totally legal. So look at that, our first trig identity. All right. So those of you all in pre-calc, again, you want some trig identities done, you can put them in the chat. You can put them on the Everyone Loves Math over here. Everyone Loves Math hotline right there. You could go on to everyonelovesmath.com and put them in the message board. All kinds of ways to ask questions. And if you put a question in between, between now and about 6 o'clock, 6 o'clock tomorrow, then your question could be shown on Everyone Loves Math tomorrow night. In fact, it almost certainly will be, because I want to help you. All right, that's it, man. It's 9:58. It's time to sign off for a Monday, and y'all stay classy. We'll see you back here on Tuesday at 9.